In March 2025, photos leaked from inside a Huawei facility in Dongguan, China. The photos showed a machine. Not just any machine. The most complex piece of manufacturing technology ever built by human hand. A machine that, according to every Western expert, every semiconductor analyst, and every U.S. government official, should not exist inside China. Not now. Not for another 10 to 15 years. They were wrong. To understand why this matters, you need to understand what EUV actually is. Think of building a computer chip like printing an insanely detailed map onto a piece of silicon the size of your fingernail. The finer the detail, the more powerful the chip. To print those details, you need light, extremely precise light. For years, chipmakers used EUV, deep ultraviolet lithography, which works fine until you try to go below 7 nanometers. At that point, the light is simply too wide. That is where EUV, extreme ultraviolet lithography, comes in. EUV uses light with a wavelength of just 13.5 nanometers. A human hair is 80,000 nanometers wide. The circuits being drawn with EUV are 30,000 times thinner than that. This technology powers your iPhone, NVIDIA's AI chips, and every cutting-edge device released in the last 5 years. Only one company on the entire planet has ever built these machines. A Dutch company called ASML. Each machine costs over $350 million. It weighs over 180 tons, requires 40 shipping containers just to transport, and contains over 100,000 precision components. ASML spent more than 20 years perfecting this. When Washington pressured the Netherlands to stop selling these machines to China in 2019, the entire semiconductor world agreed on one thing: China was finished in advanced chip. Experts put a timeline on it. 15 years minimum before China could even get close. That was 6 years ago. In 2023, Huawei released the Mate 60 Pro smartphone. Western analysts tore it apart looking for the trick. There was no trick. Inside sat the Kirin 9000S, a confirmed 7-nanometer chip, manufactured inside China by SMIC without a single ASML EUV machine involved. Tech Insights, the leading semiconductor research firm, confirmed it. SMIC achieved this using older DUV machines through a technique called multi-patterning, running 34 lithography steps where EUV needs only 9. One engineer described it as painting the Mona Lisa with a house painting brush. It costs 40 to 50% more than what TSMC charges for the same chip. The yield rate sat between 50 and 60%, compared to TSMC's 90% plus. The physics said it was impossible. SMIC did it anyway. Now back to those leaked photos from Dongguan. The equipment spotted inside the Huawei facility was identified as an EUV lithography objective lens assembly from the Chongqing Institute of Optics. The underlying technology is called LDP, a laser-induced discharge plasma, developed at the Harbin Institute of Technology. Here is where it gets genuinely interesting. Huawei did not copy ASML. They invented a completely different approach. ASML's machines fire a high-powered laser at microscopic tin droplets flying through a vacuum 50,000 times per second, creating plasma hot enough to emit 13.5 nanometer light. Huawei's LDP method vaporizes tin between electrodes and hits it with a high-voltage electrical discharge instead. The result is the same 13.5 nanometer wavelength, but through a fundamentally different mechanism. The system reportedly uses 40% less power than ASML's approach. The patent for this technology was filed in 2023. Trial production is targeting Q3 2025. Mass production is aimed at 2026. Before you declare ASML dead and Silicon Valley finished, here is the part nobody talks about enough. The current LDP prototype generates between 100 and 150 watts of EUV power. Commercial manufacturing needs at least 250 watts. ASML's latest machines push past 500 watts. That gap is real. Even a former ESML engineer stated publicly that ESML's technical moat remains massive. Building a full EUV supply chain, the mirrors, optics, photoresists, and software, is a decade-long challenge. ESML itself relied on a global network of over 5,000 suppliers across Europe, the US, and Japan. Most independent experts believe commercial viability from China's domestic EUV is realistic around 2028 to 2030, not 2026. But those same experts said 7 nanometers without EUV was impossible. They were wrong then. The money behind this push is not a rumor. China funneled over $75 billion into domestic semiconductor development between 2022 and 2024 alone. More than 50,000 engineers were reassigned from companies like Huawei and SMIC into classified research facilities. Beijing injected $1.9 billion into Yangtze Memory Technologies in March 2023 alone. SMIC's capital expenditure hit $7.47 billion in 2023. The Chinese government subsidized 87% of SMIC's entire operating profit in 2024. This was never about profit. It was always about making sure no foreign government can ever again threaten to switch off China's entire technology sector with a single policy memo. The market already felt it. NVIDIA's stock dropped when Huawei announced the Ascend 910C, a chip delivering around 780 to 800 teraflops of BF16 performance, roughly 40% of NVIDIA's H100. NVIDIA's market value dropped $127 billion in a single day. That is not hype. That is the market telling you something real. ESML's stock dropped 7% the moment the Dongguan facility photos leaked. Meanwhile, researchers at Peking University published a paper in Nature Electronics describing an analog computing chip that processes matrix calculations 1,000 times faster than NVIDIA's H100 while consuming 100 times less energy, built on 7-nanometer technology that the United States never bothered to sanction. 3 times the world called it impossible. 7 nanometers without EUV done. 5-nanometer equivalent without EUV done. A working domestic EUV machine, in testing right now. The wall that Washington built around China's chip ambitions is not solid anymore. Every export restriction, every ban, every sanction has worked less like a wall and more like a starting gun. ESML's CEO said in December 2024 that China was still 10 to 15 years behind without EUV access. Then the photos from Dongguan leaked. The question is no longer whether China can compete. The question is what happens to the rest of the world when they do. In May 2019, the United States government made a decision it believed would end Huawei for good. The U.S. Commerce Department added Huawei and 68 of its affiliates to the entity list. Overnight, Google cut off Android access. Qualcomm and Intel stopped supplying chips. Microsoft ended its partnership, and by March 2025, Huawei's Windows license expired completely. Every analyst in Silicon Valley called it a death sentence. One prominent investor said the company would be dead within 2 years. They were all wrong. Not a little wrong. Catastrophically wrong. What the United States did not see coming was this. Huawei took every restriction, every closed door, every cut supply line, and used it as a construction permit. They didn't beg for exemptions. They built their own everything. And the foundation of that entire parallel technology world sits inside a chip most people outside China have never heard of, the Kunpeng 920. Huawei unveiled the Kunpeng 920 on January 7, 2019, just months before sanctions hit. Built by HiSilicon, Huawei's in-house semiconductor division, this is a 64-core ARM server processor manufactured on TSMC's 7-nanometer process. It runs on ARMv8 architecture, clocks at 2.6 GHz, scores over 930 on spec benchmark tests, 25% higher than industry standard, and consumes 30% less power than competitors. It supports 8-channel DDR4-2933 memory, PCIe Gen 4, and runs at a TDP of 180W. This was built for data centers, not laptop. But when Intel and AMD became off-limits, Huawei did something nobody in the industry expected. They took their server chip and repurposed it for consumer desktop. By 2020, 8-core Kunpeng 920 desktop systems were already appearing in Chinese government offices and universities, running UOS, a Chinese Linux distribution, on Huawei D920S10 motherboards, priced at around 7,500 yuan, roughly $1,068. Then came May 19, 2025. Huawei walked onto a stage in Chengdu and launched the MateBook Pro and MateBook Fold Ultimate design, the world's first laptops running Harmony OS 5 instead of Windows. The MateBook Pro starts at 7,999 yuan, around $1,100. It has a 14.2-inch OLED display at 3.1K resolution, a 120 Hz refresh rate, and weighs just 970 grams. The MateBook Fold costs 23,999 yuan, $3,328, and opens into an 18-inch foldable OLED screen with 1,600 nits peak brightness. Both machines run on Huawei's own Kirin X90, a 10-core ARM chip designed entirely in-house. No Intel, no AMD, no American technology anywhere inside them. Harmony OS is what makes this genuinely significant. This is not an Android skin. It is not built on Linux. It runs on Huawei's own Hongmeng microkernel, completely independent of any Western technology. As of 2025, Harmony OS runs on over 1 billion active devices globally. In China, it captured 19% of the smartphone market in Q1 2024, surpassing Apple's iOS, which sat at 17%. Globally, it holds 5% market share, the third largest mobile operating system on the planet behind Android and iOS. The ecosystem now includes over 8 million registered developers. By June 2025, more than 30,000 applications were available. Huawei invested tens of billions of yuan over 5 years with more than 10,000 engineers working on Harmony OS alone. This is not a startup project. This is a state-backed, decade-long infrastructure build. On November 2, 2025, Huawei released 2 desktop computers, the Qianyun W515Y and W585Y, powered by the Kirin 9000X processor. This chip has 8 cores, 16 threads, runs at 2.5 GHz, and was manufactured by SMIC, China's largest domestic semiconductor foundry, using a 7-nanometer process. These are the same chips that American export controls were specifically designed to make impossible. The previous generation desktop achieved a 98.4% localization rate, meaning nearly every single component inside the machine was designed and manufactured inside China's borders. Then on December 11, 2025, Huawei announced the HM740, their flagship Harmony OS laptop. It weighs 1.32 kilograms, measures 14.5 millimeters thin, has a 14.2-inch OLED display at 2.8K resolution, 120 Hz, 450 nits brightness, and it carries a 70 Wh battery delivering 21 hours of continuous 1080p video playback. Apple's M4 MacBook does not match that. No Windows laptop on the market comes close. Here is why this matters beyond the hardware. Intel generated $15.53 billion from China in 2024, 29% of its total global revenue. China's government policy, called Xinjiang, mandates that every government agency and state-owned enterprise must transition to domestic hardware and software by 2027. A Bernstein analyst estimated Intel faces an immediate $1.5 billion revenue hit just from government procurement stopping, and that is only the beginning. In 2024, Huawei shipped 4.2 million PCs in China, including 3.8 million laptops. Smartphone sales hit 35 million units globally with 40% year-over-year growth. Huawei's total revenue in 2024 surged past 860 billion yuan, over $118 billion, marking a 22% jump from the previous year. The fastest growth rate the company has seen in nearly a decade. American sanctions were designed as a ceiling. Huawei turned them into a floor. The computing world is now splitting into two separate ecosystems. One built around Windows, iOS, Android, Intel, and NVIDIA, and one built entirely around Harmony OS, Kirin chips, SMIC fabrication. Huawei just tested a machine that only one company on the entire planet has ever been able to build. Not copy. Not reverse engineer. Build. From scratch. And the experts who said this would take China at least 15 years are now watching their own predictions fall apart in real time. Here's the thing though. Before you believe the hype, you need to understand what's actually confirmed, what's still unproven, and why the real story is more interesting than any headline you've seen this week. Let's start with the machine itself. An EUV lithography machine is not a piece of factory equipment. It is the most complex object human beings have ever manufactured. Each one costs over $350 million, more than a Boeing 787 Dreamliner. It weighs 180 tons and needs 40 shipping containers just to move it. Inside, it fires a high-powered laser at tiny droplets of liquid tin to create plasma that emits light at a wavelength of exactly 13.5 nanometers. That light is then used to etch circuits onto silicon wafers. Those circuits are 30,000 times thinner than a single human hair. Only one company in the world, ASML, a Dutch firm, has ever successfully built these machines. It took them over 20 years and a global supply chain of more than 5,000 suppliers across Europe, the US, and Japan. That is what Huawei is trying to replicate. In 2019, the Trump administration put Huawei on the Entity List. Every American supplier, every chip partner, every software vendor was legally cut off overnight. Then Washington pressured the Netherlands to stop ASML from shipping EUV machines to China. Huawei's manufacturing partner, SMIC, Semiconductor Manufacturing International Corporation, was stuck using older DUV technology, which physically cannot produce chips smaller than 7 nanometers. The sanctions looked airtight. Western analysts called it game over. Then in 2023, Huawei shipped the Mate 60 Pro, a real 7 nanometers chip, made in China, without a single ASML EUV machine. TechInsights, the leading semiconductor research firm, tore the phone apart and confirmed it. SMIC had achieved this using a technique called multi-patterning, essentially drawing the same circuit lines multiple times with older DUV equipment to get finer resolution. Something the entire industry said the physics wouldn't allow. It happened anyway. Now in 2025, Huawei is testing something that goes far beyond that. They've built their own EUV machine using a completely different approach called laser-induced discharge plasma, or LDP. Here's how it works. ASML's method fires a laser at tin droplets to create plasma. Huawei's LDP method vaporizes tin between two electrodes and hits it with a high-voltage electrical discharge instead. Different mechanism, same result. 13.5 nanometer wavelength EUV light, the exact frequency needed to etch 3 nanometer circuit. The design is simpler, smaller, and potentially a fraction of ASML's price. A patent for this technology was filed with China's National Intellectual Property Administration in 2023. Trial production is targeting Q3 2025. Mass production is targeting 2026. Now here is where we slow down and fact-check. The patent is real. Multiple independent Chinese research teams, including one at the Shanghai Institute of Optics and Fine Mechanics and another at Harbin, have separately confirmed achieving 13.5 nanometers light source breakthroughs. That part checks out. What has not been independently verified is whether this machine actually works at commercial scale. There has been no third-party teardown, no external confirmation of output quality. The sources are patents, leaks, and state-adjacent media. So the technology concept is scientifically sound. Whether it performs reliably in a factory environment is a completely different question. The number that matters most here is yield rate. If you make 100 chips and 90 work, your yield is 90%. Commercial viability requires at least 70%. TSMC runs at 90% plus on its 7 nanometers process using EUV. SMIC doing the same 7 nanometers node with DUV multi-patterning hits around 50%. At 5 nanometers that drops to roughly 30%. At 3 nanometers using this new method, analysts estimate initial yields could be as low as 10 to 15%. That means 85 to 90 chips out of every 100 fail. Each working chip becomes extraordinarily expensive, even after China's government subsidies covering around 30% of production costs. This is the part most videos won't tell you. A patent is not a product. A lab breakthrough is not a factory. But here's what you also cannot ignore. NVIDIA, the company with a $5 trillion market cap that powers almost every major AI model on the planet, warned its own investors about Huawei's gains. That is a legal disclosure, not a press release. When Huawei announced the Ascend 910C, a chip that reportedly matches the performance of NVIDIA's H100, NVIDIA's market value dropped $127 billion in a single day. Then researchers at Peking University published a paper in Nature Electronics describing an analog computing chip that processes matrix calculations 1,000 times faster than the NVIDIA H100 while consuming 100 times less power, and they built it using 7 nanometers technology that the US never sanctioned because everyone assumed it was too outdated to matter. Jensen Huang, the CEO of NVIDIA, stood on stage at the Financial Times AI Summit in London and said directly, "China is going to win the AI race. Not might win. Will win." So here is the honest verdict. The 15-year gap is fiction. That is confirmed. 3 nanometers chips flooding the market by 2026 is also probably fiction. In March 2025, photos leaked from inside a Huawei facility in Dongguan, China. Engineers around the world opened those images expecting to find nothing. What they found instead made ASML's stock drop 7% in a single session. There was a machine sitting inside a clean room that, according to every Western semiconductor expert alive, should not exist. China had built its own EUV lithography machine. Then 3 weeks later, researchers at Fudan University published a paper in Nature describing a chip with an active layer thinner than 1 nanometer. 2 breakthroughs, 1 spring. And the blockade the United States spent years constructing started showing cracks that nobody can explain away anymore. To understand why this matters, you need to understand what ASML actually is. This quiet Dutch company based in Eindhoven makes exactly one product: extreme ultraviolet lithography machines. Every iPhone ever made, every NVIDIA GPU powering ChatGPT, Claude, every AI model you've touched. None of it exists without ASML. Their machines fire a 30 kilowatt laser at microscopic tin droplets 50,000 times per second, generating plasma hotter than the surface of the sun, releasing light at a wavelength of 13.5 nanometers that etches circuits onto silicon with atomic precision. Each machine costs $380 million, weighs 150,000 kilograms, requires 250 shipping crates just to transport, and is assembled from over 100,000 parts sourced from 800 suppliers across the world. ASML spent over 20 years building this technology. In 2019, the United States turned it into a weapon, pressuring the Netherlands to block all EUV exports to China. The logic was simple and seemingly airtight: no EUV, no chips below 7 nanometers, no advanced semiconductors, no AI dominance. Game over for Beijing. Then August 2023 happened. Huawei released the Mate 60 Pro. Tech Insights, the most respected semiconductor research firm in the world, bought units, cracked them open, and confirmed what looked impossible: a genuine 7nm Kirin 9000S chip, manufactured inside China by SMIC without a single ASML EUV machine involved. SMIC did it using older DUV deep ultraviolet equipment and a technique called quadruple patterning, running 34 lithography steps where EUV needs only 9. One engineer described it as painting the Mona Lisa with a house brush. It works. It costs 40 to 50% more per chip than TSMC's equivalent. Yields sit below 50%. By any normal business logic, it's financial suicide. But Beijing isn't running normal business logic. Between 2022 and 2024, the government funneled over $75 billion into domestic semiconductor development. Government subsidies covered 87% of SMIC's entire operating profit in 2024. More than 50,000 engineers were pulled from companies like Huawei and SMIC and redirected into classified research facilities. This was never about profit. It was always about making sure no foreign government could ever again threaten to switch off China's entire technology sector with a policy memo. Now back to Fudan University. The chip is called Wuji, a 32-bit RISC-V microprocessor built not from traditional silicon but from a 2D material called molybdenum disulfide. Its active layer measures less than 1 nanometer thick. It contains 5,900 transistors. The previous world record for a 2D semiconductor circuit was 115 transistors, set in 2017 by researchers at Vienna University of Technology. Fudan didn't inch past that record. They cleared it by a factor of 51 in a single leap. The same team built a flash memory device called POX that writes data in 400 picoseconds, roughly 25 billion operations per second, with a 94.3% yield rate in controlled lab conditions. Here's the honest truth though: this chip cannot run an app. It cannot power a phone. It cannot train an AI model. There are 80 billion transistors inside a modern processor. 5,900 is not a gap from that number. It's a canyon. What Fudan proved is that the physics work at atomic scale using 2D materials. What they didn't prove is that anyone on Earth can manufacture this at volume, because nobody can yet. But here's what matters: every hard line drawn around what China could not do has been crossed. 7 nanometers without EUV was physically impossible. It happened. The 1 nanometer research is the flag planted for the next decade. Back to those photos from Dingguan. The equipment spotted inside Huawei's facility was traced to the Chongqing Institute of Optics. The underlying technology is called LIDP, a laser-induced discharge plasma, developed at Harbin Institute of Technology. Instead of blasting tin droplets with a massive laser the way ASML does, the LIDP method vaporizes tin between two electrodes using high-voltage electrical discharge, producing the exact same 13.5 nanometer EUV radiation through a completely different mechanism, one that reportedly consumes 40% less power than ASML's approach. Current LIDP prototypes produce between 50 and 150 watts of EUV power. Commercial manufacturing requires at least 250 watts. ASML's latest machines push past 500 watts. The gap is real. Chinese officials targeted trial production for Q3 2025 and mass manufacturing for 2026. Independent analysts say 2028 to 2030 is more realistic. These are the same analysts who said 7 nanometers without EUV was impossible. That context is everything. Even a machine producing 70% of ASML's output would be revolutionary for SMIC, which is currently burning through 34-step workarounds that make every chip they produce dramatically more expensive than anything coming out of Taiwan. And TSMC is watching. In the second half of 2025, TSMC began mass production of 2-nanometer chips using gate-all-around transistor technology for the first time, with yields reportedly above 60%. Apple, Nvidia, and AMD already locked in capacity. Samsung entered 2 nanometers production too, but is stuck around 40% yield compared to TSMC's 90% at 3 nanometers, a gap that translates to billions in wasted silicon every single month. TSMC itself says it won't reach 1.4 nanometers until 2028, and true 1-nanometer mass production isn't expected before 2030. Every step of that roadmap depends entirely on ASML machines that China cannot legally buy. Meanwhile, Huawei's Ascend 910C is already shipping at roughly 780 to 800 teraflops of BF16 performance, about 40% of Nvidia's H100 at 2000 teraflop. Huawei plans to ship over 700,000 Ascend units in 2025 alone, scaling to 1.6 million chip dies by 2026. The next chip, the Ascend 910D, reportedly targets H100 level performance on specific workload. When that report circulated on April 28, 2025, Nvidia lost 2% of its market value in a single trading day before a single specification was independently verified. China currently depends on foreign chips for 60 to 70% of its AI infrastructure. By 2026, analysts project that falls to 40 to 50% as Ascend production scales. The direction is not reversing. The 1-nanometer chip is real science. The EUV machine is a real prototype. The gap is real and measured in years. But the team trying to close it has $75 billion, 50,000 dedicated engineers, and absolutely nothing to lose. Watch this space. On December 6, 2025, a patent quietly published by China's National Intellectual Property Administration stopped semiconductor executives cold. The document's title was Dry and Bureaucratic: Metal Integration Method for Manufacturing Integrated Devices, and for a few hours nobody noticed it. Then the engineers started reading, and the silence became panic. Because buried inside that filing was something that should not exist: a detailed technical blueprint from Huawei, the Chinese tech giant locked out of advanced chip-making equipment since 2019 for manufacturing 2-nanometer chip, the same cutting-edge technology that TSMC, Samsung, and Intel collectively poured over $100 billion into developing. Except Huawei is claiming they can do it without the machines they are legally banned from buying. To understand why that matters, you need to understand the machines. ASML, a Dutch company, is the only manufacturer on Earth of EUV lithography machines, the absolute gatekeepers to advanced chip production. Each one costs over $150 million. They weigh 180 tons. They require 40 shipping containers just to transport. Inside, they fire laser-produced plasma at tin droplets to generate light with a wavelength of just 13.5 nanometers. A beam so precise it etches circuit patterns onto silicon that make a human hair look like a highway. The entire semiconductor industry agreed on one thing: without EUV, you cannot manufacture chips below 7 nanometers. That was not an opinion. That was physics. Only TSMC, Samsung, and Intel had these machines. In 2022, the Netherlands blocked ASML from selling to China. The cage was complete. Then Huawei started doing things that were not supposed to happen. In August 2023, they released the Mate 60 Pro smartphone. Western analysts tore it apart looking for the trick. There was no trick. Inside sat a genuine 7-nanometer Kirin 9000S chip, manufactured by SMIC, China's largest chipmaker, using older DUV deep ultraviolet lithography machines that nobody had bothered to sanction because everyone assumed they were too primitive to matter. TechInsights, the leading semiconductor research firm, confirmed it after a full teardown. Zero ASML. Zero EUV. A chip that defied a decade of Western assumptions, shipping in a phone that sold out within minutes. Then in 2024, the Kirin 9030 pushed toward 5 nanometer equivalent performance. Every time the world drew a line and said China cannot cross this, Huawei and SMIC crossed it anyway. So what exactly is in this new patent? The method is called self-aligned quadruple patterning, or SAQP. The idea is ruthlessly simple in concept and brutally complex in execution. EUV draws an ultrafine circuit line in one single laser pass. SAQP draws that exact same line in 4 separate passes using older DUV equipment, with precision-engineered stencils and spacers guiding each pass down to atomic-level accuracy. The patent describes 5 spacer layers and exotic metals, ruthenium, copper, and cobalt, woven together to create metal interconnects spaced less than 21 nanometers apart. On paper, it is a work of engineering genius. In practice, it is one of the most expensive gambles in the history of chip manufacturing. Here is the brutal math. TSMC running their 7 nanometer process with EUV achieves around 90% yield, meaning 90 out of every 100 chips they produce work perfectly. SMIC doing the same 7 nanometers node with DUV multi-patterning hits only 50%. Drop to 5 nanometers and that bleeds down to 30%. Now push all the way to 2 nanometers. Industry analysts estimate initial yields using Huawei's method could fall as low as 10 to 15%. That means 85 to 90 chips dying on the production line for every one that survived. Chinese-made chips already cost roughly 40% more than an equivalent TSMC chip, even after Beijing subsidizes around 30% of production costs. At a 10% survival rate on 2 nanometers, each working chip becomes extraordinarily expensive. And China is doing it anyway. Because this was never a business decision. Between 2022 and 2024, Beijing funneled over $75 billion into domestic semiconductor development through state banks, sovereign wealth funds, and tax incentive. More than 50,000 of China's brightest engineers were reassigned from companies like Huawei and SMIC into classified research facilities. In 2024 alone, government subsidies covered roughly 87% of SMIC's entire operating profit. Beijing is not building chips to make money. It is building chips to make sure no foreign government can ever again threaten to switch off China's entire technology sector with a single policy memo. That is a different calculation entirely, and no amount of economic logic changes it. But the patent is only half the story. In early 2025, reports emerged that China was testing its own extreme ultraviolet lithography machine, a prototype believed to be codenamed Hyperion 1, at Huawei's Dongguan facility. The approach is completely different from ASML's method. Instead of firing high-powered lasers at tin droplets, the Chinese system vaporizes tin between electrodes using high-voltage electrical discharge, a technique called laser-induced discharge plasma, or LDP. Both methods generate the same 13.5 nanometer EUV wavelength needed for advanced chip etching. The current prototype produces between 100 and 150 watts of EUV power. Commercial manufacturing requires at least 250 watts. ASML's machines produce over 500 watts. The gap is real, but the fact the prototype exists at all was enough to send ASML's stock down 7% the day the news leaked. Meanwhile, TSMC is not standing still. Their 2 nanometer process entered mass production in 2025 using next-generation EUV with high numerical aperture optics and gate-all-around transistor architecture. They spent